My name is Jamie Parker. I'm an observability product manager at Red Hat. I cover both OpenStack and also OpenShift at Red Hat. And so I'm here and I'm happy to talk to you today about observability for OpenStack on Kubernetes, which is very cool. I will, yes. How about this? Is this better? Hey, all right, success. Okay. So traditionally, observability in OpenStack, you have a handful of services that we've used. You have Ceilometer to gather telemetry from the different services. You have syslog that can collect and transmit logs, and OS Profiler that can be used for traces. So this is a pretty traditional, pretty standard observability stack within OpenStack. But now we're seeing more and more organizations and enterprises move to OpenStack on Kubernetes. Why are we seeing that? The Rackspace keynote gave really good information on that. You have a lot of resource sharing that you can do. So you can share resources between Kubernetes, between OpenStack. So that's very useful to have that resource and hardware sharing and also operator sharing. You have a lot of deep understanding of Kubernetes administration at this point from a lot of system administrators. It makes sense to pool those resources and have those resources combined. So this is really useful. We're seeing a lot of resurgence of OpenStack on top of OpenShift. It's a very nice combination. But, oh, the complexity. Oh no, you've got services on top of services, you've got networks on top of networks, you have pods, you have containers, you have all kinds of things running around. How are we going to observe this thing? How are we going to make sure that this thing is up and running, it's healthy, it's doing what we need it to do for our users every day? We have an entire OpenStack environment to observe. That doesn't go away. We have an entire Kubernetes environment to observe. That's not going away. And then we have to observe how they're interacting together. So how are we going to do this? So you have a handful of observability tools. We see the OpenStack ones. We're familiar with those. There's also a handful of CNCF Kubernetes observability tools. What are we going to use? Well, just like we talked about a few minutes ago, let's combine these resources. Let's use both. So our ultimate goal here is end-to-end observability. We need to understand everything that originates all the way from OpenStack, all the way down to into Kubernetes, and then even on the hardware level. We want to know everything because any one of those things could be affecting our performance. So we have the three pillars of observability that we can utilize here. We have metrics. So metrics are very good at telling you that there is an issue. We have logs. Logs are extremely good at telling you what is the issue. And then we have traces. Traces are not utilized, I think, to the extent that they should be. I'm going to talk more about that in a minute. Traces are very good at telling you exactly where the issue lies. So our goal here is how are we going to use these three things to get our full end-to-end story of OpenStack on Kubernetes and getting it running nicely and reliably. So let's start with metrics. We use Ceilometer, of course, now in OpenStack. Ceilometer is very good. Ceilometer integrates with OpenStack services. You can use Ceilometer agent for your compute nodes. You can use Ceilometer in many different ways. There's no need for us to stop using Ceilometer. We're just going to combine it. So we're going to combine Ceilometer with Prometheus. We're going to use the Ceilometer Prometheus exporter, and we're going to use Prometheus to collect our metrics from both OpenStack and Kubernetes. You have all of your metrics there, so you have a deep understanding of your entire system that's running, both OpenStack and Kubernetes together. We can also, if this is a newer environment, so we're new to this, we might want to consider OpenTelemetry. OpenTelemetry is very useful in lots of ways. I'm going to go into this more in a minute. So OpenTelemetry has a Ceilometer receiver. You can send your Ceilometer metrics directly into OpenTelemetry. OpenTelemetry has a lot of transform filters, a lot of export options. One of the big things today has been data sovereignty. OpenTelemetry has native PII filtering and lots of other things that you can do with your telemetry data before it goes off cluster. The one thing about OpenTelemetry is that you do have to bring your own storage, but we're going to talk a lot about that in just a few minutes. So these are some things that you might want to consider if you need to balance your OpenStack and Kubernetes metrics. All right, so now let's talk about logs. Logs are one of the most critical pieces of observability signals that there are. Syslog, already supported in OpenStack. Syslog is great. It is a standard protocol and understood by many analytics engines, and you can use it to export the logs off of the services, export the logs off the compute nodes, so no change there. We are already familiar with Syslog. What are some other tools that we can use to combine that? Vector is a very good Kubernetes-based log routing system. Vector can receive logs, can collect logs, and forward those logs. Vector has agents. You can choose to run those on your compute nodes, or you can go ahead and export those via syslog into Vector. Vector is Rust-based, very fast, very scalable. So you can use it to pick things up off of Kubernetes and OpenStack at the same time. Very good, very strong. So Vector is one that we actually use at Red Hat, so I'm pretty familiar with this one, would highly recommend it. You also have the OpenTelemetry collector here too. So OpenTelemetry can collect metrics and logs and traces. Very powerful. So if this is a new system you're building, OpenTelemetry is absolutely something that you should consider. OpenTelemetry has an rsyslog receiver, so just like Vector, it can receive those metrics off of the compute nodes, off of the services. It can do those same filtering options, those same transformation options. You need to send them off cluster, you want to filter for PII first, you can do that. So OpenTelemetry Collector is absolutely something, another one that you should consider here. And then now let's talk more about tracing. Again, like I said in the beginning, tracing is not something that I think is utilized enough. So tracing, think of them as super logs. Traces consist of a span. So the span has information about all of the places that it has been. The span can tell you what services it's touched. The span can tell you how long that it has spent in those services. If you're running a system as complex as OpenStack on Kubernetes, tracing is going to be your best friend because the tracing can go all the way from the compute node, even the application that's running on it, all the way down to the hardware level, get collected, and show you immediately where the bottleneck might lie within your system. If you combine the traces with the logs and the metrics, then you can very, very quickly reduce a lot of the complexity that you're going to see with these systems, distributed systems. So again, traces, super logs with context and timings. So in a big system, your best friend. So what can we use for tracing? OS Profiler, I mentioned it. So this has been historically the tracing for OpenStack. It already supports the OpenTelemetry SDK and OpenTelemetry exporters, so you can be set with OpenTelemetry there. If you're building a new system, again, you may want to consider that. OpenTelemetry was actually built for traces. This is the second largest CNCF project behind Kubernetes. OpenTelemetry has very, very strong tracing support. OpenTelemetry is also going to be a thing that you can use for more than that. Again, filtering, transformations, you need different things to look different ways because you want to export them to different systems. And OpenTelemetry can do all of that for you. So that's going to be a huge tool in combination with OS Profiler. So very good for you to use. And then also mentioning Jaeger. Jaeger is another very popular CNCF project. Again, Jaeger is Zipkin based, so not quite as useful. Zip can be a struggle on OpenStack. But the combination of OS Profiler and OpenTelemetry is going to give you a very, very strong base for your traces. But what about my applications? Well, the good news is that all of these products that I've mentioned already have ways to collect the metrics, the logs, and the traces emitted by your applications. One more thing about OpenTelemetry, it has auto-instrumentation libraries. So OpenTelemetry has a means to inject instrumentation into your applications as long as they are .NET, Java, Node, Python, or Go based, which many of them are. So if you have a legacy stack, you're struggling with getting some metrics out of it, you're struggling with getting that instrumented, You can use the libraries from OpenTelemetry and the OpenTelemetry metrics auto injection, and you can get some preliminary observability out of your applications. So this is an excellent way to go if you don't have metrics for your applications already. You got to put the stuff somewhere. So we got to store it. So we have a lot of stores that can be utilized in both Kubernetes and OpenStack. So you have your metric store, Prometheus, I mentioned earlier. Prometheus is also a metric store. OpenStack is a little bit unique in that OpenStack has a hard tenancy model. There is a newer product from Grafana that's open source called Mimir. Mimir gives the tenancy model to your metrics. So if you have something where you're running a tenant environment that has a hard tenancy model for your customers or for your users, you may want to consider Mimir for tenant storage because it'll just be easier to pull those multi-tenant metrics out of Mimir. For logs, Loki is a very fast, very scalable S3-based log storage tool. Very quick, very easy to search, highly recommended. OpenSearch is another good option. So this is a fork of, kind of a fork. This was a diversion from Elastic. So if you're used to Elastic in your environment, you may want to consider OpenSearch. Again, another very powerful log storage tool, very good at searching as well. And then for traces, Tempo, very similar to Loki, also has strong storage for tracing, and then OpenSearch can store traces as well. So good recommendations for storage because you need to store all of these observability signals so that you can do analysis, you can understand what's happening, do the research into what might be causing your bottlenecks and your issues. And very last thing, so we've got it stored, we've got it collected, now how do we look at it? There's two really great tools for looking at this observability data. Grafana is classic. Grafana, the open source version, is very powerful, supports visualizations from many storage options. All of the ones that I listed before, you can visualize from there. Another one that we have been working with at Red Hat is called Persis. This dashboard that you see is actually from our Persis implementation. Very similar to Grafana, you can visualize from your storage options. There's two things that we really appreciate about Persis and why we would recommend it. It's embeddable. So if you have a website that you're working with and you need to embed a dashboard into that, you can do that quite well with Persis. It also provides dashboard as code options. So if you are going into your OpenStack deployment on Kubernetes and you're wanting to have CI/CD pipelines, you're wanting to do infrastructure as code, you can define your dashboards as code as well. You could define a standard series of dashboards, send them to your users will know that they will be there. Very quick, very easy. Persis is a very powerful open source tool. So again, we recommend it. All right. So with all of these tools together, we've combined our OpenStack tools. We can observe our OpenStack environment. We understand what's happening there because we've got our metrics, we've got our logs, we've got our traces. We've also got our Kubernetes environment. We have metrics, we have logs, we have traces there. So we can understand the health of our OpenStack environment. We can understand the health of our Kubernetes environment. And we got some bonus management tools. So we have bonus management through alerts. Prometheus is very good at alerting. Some of these other tools provide alerting as well. We have storage, so we can keep our signals, we can analyze them, compare them. And we have visualizations, so put it all together. So success. Big success. We've achieved end-to-end observability. Fantastic. But wait, there's more. Some other observability tools that are really going to be quite useful. You have all of these things. How do you analyze them? How do you get to this mean time to resolution even more quickly? You can use an open source project called Correlator. So Correlator is an observability tool. It will correlate these observability signals for you in a Kubernetes cluster. So if you've got your metrics, your logs, and traces from OpenStack stored, then you can also use Correlator to correlate these tools. So it can correlate metrics, logs, traces, and net flows, which I'll talk more about in a second. So this will give you a faster way to resolve the issues in, again, a very complex environment, just even more, making your end-to-end observability even stronger. NetObserve. This is a really powerful tool for understanding network flows. So these are the network flows that Correlator can also work with. This is eBPF based. It generates the network flows from the packets that go through it. And it can make those available through Prometheus metrics, through Loki. It can store all of these net flows in Loki as well, and then export them to a collector. It can also export to OpenTelemetry. So this is, if you're needing help with your network environment, which again, we have OVN on SDN on all the things down to the hardware layer, network observability is a good option. eBPF in general. There are more and more tools coming out that are eBPF based. It's very lightweight, very powerful. It gives you some very strong observability capabilities and works really well in a disconnected environment because it can communicate with the Linux kernel directly. So there are some pretty useful tools that I wanted to list here. BPF will manage all of your BPF deployments. Coretta is a way to map Kubernetes dependencies if you have a need for that. That's eBPF based. Network observability, of course, and then Kepler for monitoring your power utilization. Speaking of Kepler. So Kepler is a Kubernetes-based power level exporter. This uses eBPF to get CPU performance. This works, since it's eBPF-based, it works equally well in Linux, and it will work in OpenStack. So this is a way that you can monitor the power utilization of your OpenStack nodes. So very useful, and then export the data to models so that you can analyze and get an idea of how to reduce that power consumption. So I included some resources here. I think that they're going to make these slides available. So when they make these slides available, everything that I've talked about is linked here. So you can get links to all of these. Some of these you'll be familiar with, Ceilometer, OS Profiler. And then some of these maybe not quite as familiar with. So this is links to all of the open source documentation and downloads for you so that you can explore these and figure out which ones work best in your environment. And thank you. I appreciate the time. And I don't know, do we have a question? Second? Okay, I think there's questions. Yes?
You mentioned strong tendency of behavior. Is there something similar for logs?
So Loki has a tenancy model as well. And you can also extend the Loki tenancy model. So yes, Loki. Other questions? Okay, well, in that case, thank you very much. I appreciate it.